Hi Flashes! So today we are going to be talking about tree diagrams, the counting principle, and sample space. So a couple of vocab words that you guys need to know. First one is sample space in a probability experiment. So let's say you are you're looking in your closet and you have some shirts and some pants and you're trying to figure out what shirt you can wear with what pant. Well, today I'm going to teach you guys a way that you can figure that out and then figure out how many different combinations you would have. And that way that I'm going to teach you guys is using a tree diagram. So a tree diagram is a method used to find the number of possible outcomes using branches. And that's why it's called a tree diagram, because we are using some branches. Okay? So you guys can pause this video if you need to write down those definitions, but I'm going to go ahead and move on. So this first example says a sandwich shop makes egg salad, tuna salad, or tomato salad sandwiches using either wheat or rye bread. Find the possible sandwich combinations. So we are going to use a tree diagram to set this up. So to create a tree diagram, whatever they give us first, the different options that they give us first, is going to be our first column in the tree diagram. And you guys are more than welcome to abbreviate. Just make sure that you tell your teacher how you are abbreviating it. So for like egg salad, tuna salad, tomato salad, instead of like including salad, I'm just going to say egg, tuna, and tomato. So I'm going to create a column that says egg, tuna, and tomato. And you do want to give yourself a little bit of room so that when you make your branches, you're going to have plenty of room to make them. Okay, so those are the first three options to choose from. So if you were the one going into the sandwich shop, you can choose egg salad, tuna salad, or tomato salad. So whatever your different options are, that's your first column in the tree. Then you move on to what you will choose next. So you can have those different types of salads on wheat bread or on rye bread. So since there are two options that you can choose after your first option, since there's two options, you're going to have two branches, and that's what we call branches right here. You're going to have two branches coming off of your first option, and you just have to write down wheat or rye bread. So I'm going to write down off the first branch wheat, and off the second branch rye. And then same thing, off the first branch wheat, off the second one rye, first one wheat, second branch rye. So this is how you create your tree diagram. So again, you always start with your first option. Whatever you're choosing first, that's your first column. And then your second column in your tree is going to be your second option. And depending on how many options you have, that's how many branches you are going to have off of each first option. Because when you go to read this tree diagram, this means that you can pick egg salad with wheat bread, or you can pick egg salad with rye bread. Or let's say you don't pick egg salad. Let's say you pick tuna salad with wheat bread, or you can do tuna salad with rye bread. Or let's say you don't pick tuna and you pick tomato salad. Well, you can pick tomato salad with wheat bread, or you can pick tomato salad with rye bread. So you just are listing all the different options that could happen. And then you just have to list them in the sample space. So again, the sample space is all the different kinds of options that you can have. So you just have to list them. So the first one, you can have egg salad with wheat bread. So you just have to write egg and wheat. Again, you're more than welcome to abbreviate if you like. Or you can have egg with rye. So that takes care of the egg branch. So now we're moving on to tuna. So now you can have tuna with wheat. Or you can have tuna with rye. And that takes care of tuna. So now we're moving on to tomato. So now you can have tomato with wheat, or you can have tomato with rye. So you just have to list all the different options that we have. And the easiest way to figure out if you listed all the options or not is to count how many words do you have in your last column. So if I were to count, I have let me just write it. 1, 2, 3, 4, 5, and 6. So I have 6 different options here in this last column. So in my sample space, I should have 1, 2, 3, 4, 5, and 6, which I do. So that is just a good indicator to make sure that you listed all of your options and in the sample space or not. Okay, so let's try another one. So Tommy is going on vacation and only wants to take 4 shirts and 3 pairs of shorts. Find the possible outfit choices. Okay, so I think in this one, because you do have to depict on the different pants and the different shirts that you guys have, I am just going to label them as like shirt 1, shirt 2, shirt 3, and shirt 4 to help us in our tree diagram. So again, whatever option is first, so in this case we are going to be choosing from 4 different shirts, that is your first column in the tree diagram. So in my tree diagram I have shirt 1, shirt 2, shirt 3, or shirt 4. Because again, if he wants to take 4 shirts, that means that he has 4 different shirts to choose from. So that's my first column in my tree diagram. Then you go on to your second option. So your second option is choosing between 3 pairs of shorts. So if you're choosing from 3 pairs of shirts or shorts, that's 3 different options. So you should have 3 branches coming off of each option before. So on all the different shirts, we should have 3 branches coming off of it, because we're going to put down the 3 different shorts that we have. And then you just have to label them. So if I have 3 different pairs of shorts, this could be short 1, short 2, or short 3. And then just keep doing that for all these branches. So short 1, short 2, or short 3, short 1, 3, short 1, short 2, and short 3. Okay, so again, your first option that you're choosing from is your first column in the tree diagram. Then whatever your second option is, that is your second column in your tree diagram. And you just want to make sure that however many options there are, that's how many branches you have coming off of this. So let's say like they wanted to add shoes. They have 4 different shoes that they're choosing from. Then I would make 4. Sorry, my video paused. So let's say I wanted to add like shoes onto this, and he has 2 different pairs of shoes to choose from. Well, then I'm going to include 2 branches off of each of these pairs of shorts to include what kind of shoes he could choose from. Okay, so you're just always adding branches onto the last column depending on how many options your next situation is. Okay, so let's see how many different options we can choose from. So again, to figure out how many different combinations you have, you just add your last column. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possible outcomes. And again, I just got that by adding up this last column. So when it says list the sample space, remember the sample space is listing all the different combinations that there are. So if there's 12 possible outcomes, you should have 12 different possibilities down here at the bottom. So again, you just follow your tree. So you follow the branches. So you can wear shirt 1 with short 1. Or you can wear shirt 1 with short 2. Or you can wear shirt 1 with short 3. So that's all the different combinations you can make with shirt 1, okay? So after you get done with shirt 1, then you move on to shirt 2, and you start listing those different combinations. So you can wear shirt 2 with short 1, or shirt 2 with short 2, or shirt 2 with short 3. So that takes care of these two branches. Now we can move on to shirt 3. So we can wear shirt 3 with short 1, shirt 3 with short 2, or shirt 3 with short 3. Alright, and then the last one is moving on to shirt 4 and listing all those different combinations. So you can wear shirt 4 with short 1, shirt 4 with short 2, or shirt 4 with short 3. Okay, and again, if we knew that we were going to have 12 different outcomes, you better have 12 different options down here at the bottom and listing them all out. So if I were to actually count these, I do have 12. So I did not miss any of them. And the easiest way to do it, guys, is to literally just follow the tree. So start at the top and then work your way through those 3 branches. Then you move on to the second one, work your way through those branches, and then you just keep going on until you get to the bottom. Okay? Alright, so there is one more tree on the back side of these notes that we will do to practice, and then I'll talk about the counting principle. So this one says, suppose you toss a quarter, a dime, and a nickel space. Okay, so this one is going to include our probability because a lot of students are going to see, oh, quarter, dime, nickel, so they're going to put Q for quarter, D for dime, and N for nickel, okay? But we are talking about the different outcomes that can happen. A tree diagram is all the different possible combinations that can happen. So when you toss a quarter, a dime, or a nickel, what are the 2 different outcomes that could happen? Well, it can land on heads, or it can land on tails. So my first column is going to be talking about the quarter. So on a quarter, when I toss it, it can either land on heads, so I'm just going to use H for heads, or it can land on tails, so I'm going to use T for tails. Then we can move on to the dime. So our second one is the dime, so in my second column, I'm going to be talking about the different options that can happen with a dime. Well, once again, when you toss a coin, there's only 2 options, and that's heads or tails. So since there's only 2 options off of each of my first options, I'm going to have 2 branches. Because if there's 2 options for a dime, I should have 2 branches coming off of my first option. And again, those options are heads or tails. Heads or tails. Okay, and then this is the first time that we actually have a third event that's happening. So now we are tossing a nickel. Okay, and for our nickel, again, if we are tossing it up in the air, what are the 2 different options that can happen? Well, it can land on heads, or it can land on tails again. So since there's 2 options, once again, off of all the options, so once again, since there's 2 options, out of all of the options before, I should once again add on 2 more branches. So you're always adding on how many branches depending on what are the different outcomes that can happen. So like I said, with a nickel, it can land on heads or tails, so that's 2 options. So I should have 2 branches going off of each thing that was before it. And again, it's going to be heads and tails. So heads, tails, heads, tails, heads, tails, and heads, tails. And then that's it, because we're only tossing 3 coins, and I have my quarter, I have my dime in the second column, and then I have my nickel in the last column. Okay, so this is your tree diagram. So let's see how many different outcomes we have. So remember, to find out the different outcomes, you just count your last column. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 outcomes. Now, they do tell us to find the sample space. So once again, that means that you're writing down all the different options that could happen. So let's go ahead and do that. So our first one, so you're just following the branch. You can toss the quarter heads, toss the dime on heads, and toss the nickel on heads. So our first outcome would be heads, heads, heads. Then we're not done with this branch, so once again, you can toss the quarter at heads, toss the dime at heads, or toss the nickel at tails. So notice how I'm just following the branches. So after I get done with this last branch, I then move down to this branch. So my next outcome would be heads, heads, tails. And that takes care of this branch. So now I'm done with this whole branch. Now I'm moving on down here. So now I can do heads, tails, heads. Or I can do heads, tails, tails. So these are the different outcomes that can happen if I toss the quarter heads. Okay, so this whole branch are these outcomes. Now I move down to the bottom one and do the same thing. So I can do tails, heads, heads. Or I can do tails, head, tail. So that got done with this branch. So now I move on down here. So now I can do tail, tail, head. Or I can do tail, tail, tail. Alright, so that is our sample space. So again, we said there were 8 outcomes, and I do have 8 different outcomes that can happen. So as you read your sample space, you're doing it in order as you made your tree diagram. So first outcome's talking about the quarter, second outcome is talking about the dime, and then your last one is talking about the nickel. Okay, so down here when it says what's the probability of tossing 3 heads, well, how many 3 heads do we have in this outcome? We only have this one. This was the only outcome that was heads, heads, heads. So there's 1 out of 8 outcomes, so that means that our probability would be 1 out of 8. So tree diagrams are nice because it is more of a visual to see all the different outcomes. However, when you start getting bigger numbers, because as we know, if we were to go to Subway, there are a lot more than just 2 different options for bread, for meat, for veggies, for everything that is included. So there is something called the counting principle that makes things 10 times easier. So the counting principle is a method used to find the number of possible outcomes using multiplication. So all that we have to do is multiply the different outcomes that we have together, and then that will give us the total combinations of everything. So for example, this one says a yogurt shop offers 18 flavors of yogurt, 3 types of cones, and 12 different toppings. Assume a frozen yogurt is a combination of 1 cone, 1 yogurt flavor, and 1 topping. Find the number of possible frozen yogurt combinations. So again, you could use a tree diagram, but do you see how if we start with 18 different options to begin with, it's going to be impossible to fit 18 different options in one column. then go to 3 types of cones, and then 12 types of different toppings. So that would just take forever. So we have the counting principle. So what that is you are just going to multiply the numbers for the different events, and that's going to give you your total different options. So the first thing that we have to choose from is the flavor. And how many different flavors are there? Well, it says that there's 18. Then you're going to multiply that by your second thing that you're choosing from, which is the type of cone. And how many different types of cones are there? Well, there's 3. And then we still have one more thing to choose from. So we still have one more thing to choose from, and that's the different toppings. And how many different toppings are there? 12. So the counting principle tells us that we can just multiply all 3 of those numbers, and that will give us our answer. So if you were to take 18 times 3 times 12, that will give you 648 yogurt combinations. And that's it. So counting principle is super nice because that's all that you have to do. With the tree diagram, you would have to set up the tree diagram, then list all the different outcomes to figure it out. So like I could have used the counting principle here because I knew the quarter, it can land on heads or tails, so that's 2 options. A dime can land on heads or tails, so that's 2 options. And a nickel can land on heads or tails, so that's 2 options. So if I were to just take 2 times 2 times 2, notice how that would give me 8, and that's how many different outcomes that we had. Okay, so students love the counting principle compared to the tree diagram. Alright, so let's try the next one. So a hot dog stand sells 2 sizes of hot dogs, 6 kinds of soda, and 3 sizes of soda. Find the number of possible choices. So again, the counting principle says whatever you're choosing from, you can just multiply those numbers together to get your answer. So since the first thing that we are choosing from is the size of the hot dog, you just need to multiply or give me that number for how many different sizes of hot dogs they have. Well, they only have 2 sizes. Then give me the second option. So now we're choosing the kind of soda. And it says that there's 6 kinds of soda, so I'm going to take 2 times 6. And then the last thing that we're choosing from is the size of soda. And it says that there are 3 different kinds of soda. So all that I have to do is multiply those 3 numbers together, 2 times 6 times 3, and that gives me 36 possible outcomes. Okay, so you guys try the last one, see if you guys can do that one on your own, and then pause the video and play it when you're ready. So you guys should be done with this one. So let's see how you guys did. So it says Tia is getting ready for spring break. She packs 5 shirts, 3 pairs of shorts, and 2 pairs of sandals. How many possible outfit choices will she have? Okay. Well, the first thing that you're choosing from is a shirt, and it says that there's 5 shirts, so that's the first number that you should have multiplied. Then 3 pairs of shorts, so 5 times 3, and then 2 pairs of sandals, so 5 times 3 times 2. So 5 times 3 times 2 would have given you 30 possible outfits. And that's it. Okay, so like I said, we could have created a tree diagram. So like I could have done shirt 1, shirt 2, shirt 3, shirt 4, shirt 5, and then 3 pairs of shorts. So I'm going to have 3 branches, and then I could have had 2 pairs of sandals, so I would have had 2 branches off of each of those. So yes, I could have created a tree diagram, but if you notice, when we get to the bigger numbers, this tree diagram is going to get insanely impossible to read off of, because my tree diagram would look something like that. So when you get to those bigger numbers, it's super nice that you can use the counting principle to get your answer, okay? Just know though, on your guys' test, we are going to tell you guys to do both. You have to create a tree diagram for some of them, and then you're going to use the counting principle for the bigger numbers, okay? So just let your guys' teacher know if you guys have any questions, but that is it. Thank you.